Hey there, tonight we're going to drift far, far ahead. Past tomorrow, past the end of the week, past even the end of Earth. We're setting out to see something that doesn't come with a date on the calendar. Tonight, we're gliding into the long, slow hush that waits for the universe itself. So before you get comfortable, take a moment to like and subscribe to the video, but only if you really enjoy what I'm doing here. And while you're settling in, post your location and what time it is where you are. I love seeing where in the world we're all listening from. Now dim the lights, maybe turn on a fan for that soft background hum, and let's start our journey together tonight. Time is moving, always moving. But what we don't often feel is that it's also unraveling. Quietly, softly, like a candle running out of wax, not suddenly, not tragically, but inevitably. Every breath you take, every warm current in the ocean, every light bulb that flickers, all of it leaves a tiny mark on the great ledger of entropy. You've probably heard the word entropy tossed around in science videos before. It's often explained as disorder, but it's more accurate and more poetic to think of it as forgetting. The universe, with every passing moment, forgets a little more of the structure it used to hold. What was once organized becomes loose. What was once hot becomes cold. What was once alive becomes still. But here's the odd part. This process started long before you, me, or Earth. The moment the Big Bang erupted into being 13.8 billion years ago, the universe was set on a one-way path. Expansion, cooling, and eventually silence. This isn't a horror story. This is a bedtime story, told by the stars that are still burning while they can. It's not a tale of doom. It's a lullaby sung in the long exhale of time. Right now, the universe feels so alive. Galaxies spin, planets orbit, suns roar. But even as you read this, there's a very slow, invisible process at work. Galaxies are moving apart, so slowly you wouldn't notice without a telescope and a few million years of patience. Energy is being used up, bit by bit. And everything that's hot is gradually leaking its warmth into the chill of space. This is what cosmologists call the arrow of time. And like a feather falling toward the ground, it's gentle, but there's no turning back. Let's pull back for a moment. Imagine the universe as a warm lit house on a winter night. All the lights are on. The fireplace crackles. Music is playing. People are dancing. That's us, right now. Life, stars, motion. But little by little, the lights will start to dim. One room at a time, the fire will become embers. The music will slow. And eventually, the house will still be standing. But it will be dark, and cold, and quiet. The idea might sound sad, but it doesn't have to be. There's a quiet grace in watching the last light fade. There's something soft, even comforting, in knowing that we are part of this slow drift, that our stories are written on a canvas that stretches billions of years in both directions. Now, just for a moment, let's imagine the future, not 1,000 years ahead, or even 1,000,000. Let's think trillions of years. The stars we know now will be gone. The galaxies we see today will have drifted beyond the reach of any telescope. Light itself will be a rare thing, but that journey has already begun. The future isn't waiting, it's already unfolding, like a petal made of darkness. And tonight, we'll trace it gently, piece by piece, all the way to the quietest moment in the cosmos. And don't worry, you won't need a spacesuit. Just your imagination. Ready? Let's follow the light while it's still shining. You'd think the end of the universe would be loud, explosive, some kind of grand, cosmic finale with fireworks and dramatic music. But no, if you're waiting for a bang, you'll be waiting forever. Because the most likely ending doesn't explode. It whispers. It forgets. It fades. Welcome to what physicists call heat death, though the name is wildly misleading. It's not hot. It's not fiery. It's more like the death of heat. The moment when every usable spark of energy has been spent, and the universe is stretched so thin, so cold, that nothing can do anything anymore. To understand it, let's go back to something simple. A cup of coffee. Let's say you make yourself a nice warm drink on a chilly morning. At first, it's steaming, alive, full of energy. But if you leave it on the table long enough, what happens? It cools, not because anything stole the heat, but because it shared it. With the air, with the cup, with the table. The energy didn't disappear. It just got diluted. That's heat death. On a cosmic scale. Right now, stars are still shining, galaxies are colliding, and life is dancing across planets like Earth. But energy is being spent. Each act of warmth, every spark of motion, contributes to the slow equalizing of the universe. The universe is trying to even itself out, and someday it will succeed. According to mainstream cosmology, this end state called maximum entropy means everything will be the same temperature. Everywhere, forever. No gradients. No differences. And if nothing is hotter or colder than anything else, well, nothing moves. Nothing happens. There are no batteries to run, no suns to shine, no wind to blow. Just stillness. Here's something a little weird. Scientists actually use the word death for this, not because anything dies in the traditional sense, but because useful energy disappears. It's the universe turning into a room temperature soup. Technically full. Emotionally empty. Now, here's a more fringe idea. Some physicists have speculated that heat death might not be truly final. That somewhere, in some corner, quantum fluctuations could briefly undo the silence. That maybe, just maybe, little blips of temporary order could arise from the chaos, like bubbles in an otherwise flat soda. But those moments would be rare, fleeting, ghost stories whispered in an otherwise silent night. And what does that silence feel like? Imagine being in a place where every direction is the same, where there's no light, no gravity wells, no warmth. A place where nothing is pulling on anything else. Just a quiet, cold drift with no destination. That's the universe in heat, death not destroyed, but fully worn out. Like an old book whose pages have all been turned. Nothing left to read. And yet, strangely, it's beautiful, because that future was earned. Every burning star, every swirling galaxy, every heartbeat, it all happened before the silence. The universe didn't waste its time. It burned. It created. It danced. And now, it rests. So tonight, as you breathe slowly and let your eyes grow heavy, imagine yourself floating gently into that far-off future. There's no fear here, no hurry, just a gentle dimming, a cosmic bedtime. And you were part of the chapter with the most light. You lived during the glow, during the heat. Let that comfort you as the darkness folds around us. As you drift further into this slow cosmic evening, picture the stars still twinkling above you. For now, they feel eternal, constant, like old friends who will always be there when you glance up. But that's just a story light tells your eyes, because every star is burning through its own countdown. Some go quickly big, brilliant ones that burn hot and die young in a blaze of supernova glory. Others, like our sun, stretch their lives into billions of years. And then, there are the quiet ones, the slow burners, the cosmic turtles. Enter the red dwarfs. These are the smallest and most efficient stars in the universe. They sip their fuel like monks on a budget, barely visible from Earth. Most red dwarfs aren't bright or flashy, but they are survivors. While stars like the sun have lifespans of around 10 billion years, red dwarfs can last trillions of years. That's trillion, with a T, as in, longer than the universe has existed so far. Much longer. So when the flashy stars have all gone dark, when galaxies have stopped colliding and the cosmos has grown quiet, red dwarfs will still be out there, flickering gently, like candle flames in an endless dark hallway. Mainstream astronomers believe that red dwarfs will be the final stars to burn out. They'll live well into the late chapters of the universe, shining faintly while everything else slips away. Some of them might even host planets. And who knows, maybe life will cling to their warmth until the last possible second. Fringe theorists have even speculated that advanced civilizations might gather around these long-lived stars like campers around the last embers of a dying fire, stretching out warmth and light for as long as possible. It's a sweet, almost romantic vision, quiet, slow, and fiercely hopeful. But even red dwarfs will eventually run out of fuel. And when they do, they won't go out with a bang. They'll just dim, cool, fade into what's called a black dwarf, a cold dark star remnant that no longer glows. And since the universe isn't old enough yet for any black dwarfs to exist, they remain purely theoretical. Think about that. A star remnant that we know must exist someday, but hasn't had time to form yet. The universe is still too young. For its own death story, there's a strangely tender rhythm to it all. First, the big stars burst and vanish. Then, the medium ones fade and swell and shrink. And finally, the red dwarfs carry the torch slowly, stubbornly, until even they give in to the chill dot. By the time the last red dwarf breathes its last photon, the sky will look nothing like it does now. There will be no constellations, no familiar patterns, just scattered, cold relics floating in darkness. And yet, it won't be empty. The universe never really is. Even in the silence, things remain. Electrons still hum. Atoms still drift. And the memory of every light that ever shone will linger in the thin cosmic fabric, like echoes of laughter in a house long since quieted. So as you close your eyes tonight, think of a small red star, far away, burning slowly with all the time in the world. It doesn't need to rush. Neither do you. The night is long. Let's stay with it. Now let's zoom out, way out, beyond the stars, beyond the scattered systems that still flicker with life and warmth. Let's drift across the galactic sea and look at the larger picture. Entire galaxies, slowly winking out like street lamps. On a quiet road at dawn. Galaxies, as you know, are colossal. They're cities of stars, hundreds of billions of suns, swirling together in grand spirals and fuzzy ovals. And for now, they're alive with energy. Stars being born, others dying. Black holes stirring quietly at their hearts, like sleeping giants. But here's the uncomfortable bedtime truth. Galaxies are running out of fuel. Stars are born in nebulae clouds of gas and dust that collapse under gravity, kickstarting nuclear fusion like cosmic lighters. But this raw material is finite, and galaxies are using it up. Right now, the Milky Way still has some star-making juice left, but it's past its prime. Most of the star formation happened billions of years ago. What we're seeing now is a slow decline. The golden age has passed. Here's a mainstream fact. According to most models, the star formation era of the universe is already winding down. In a few trillion years, new stars will be a rare sight, like forgotten antique stores still open in empty towns. Now imagine that, galaxy by galaxy. As stars die and aren't replaced, galaxies grow dimmer. Some will become nothing more than quiet clumps of dead stars and black holes, drifting in the cold like fossils. But there's a strange twist. Galactic mergers. Even in the far future, galaxies will still occasionally collide. Not in fiery explosion. Space is mostly empty, but in slow, swirling dances where stars pass harmlessly by and black holes spiral together. These mergers will continue even when the stars themselves are fading. Some astronomers think the last fireworks of the universe might not be from stars, but from black hole collisions in ancient, lightless galaxies. Now, here's something more speculative. Some cosmologists suggest that as galaxies go dark, civilizations, if they still exist, might attempt to migrate between them, searching for warmth, for energy, for fuel. A grand exodus across the void. Entire species hitching rides on intergalactic ships, not unlike embers blown by cosmic winds. Of course, this is imagination stacked on speculation. But then again, the universe has never lacked ambition. And let's not forget the ultimate irony. The universe is expanding, accelerating even. Galaxies are moving away from each other faster and faster, pushed apart by dark energy. Which means, one day, distant galaxies will be so far away, their light will never reach us. The night sky won't just be darker, it'll be emptier. Like a house whose windows have all been boarded up, the Milky Way and its neighbor Andromeda will likely merge first, forming one large elliptical galaxy nicknamed Milkdromeda by astronomers who apparently skipped lunch that day. After that, silence. Imagine it. A sky no longer filled with twinkling lights, but mostly black. Maybe one or two faint glimmers, like the last embers of a dying fire. Maybe none. But this isn't a sad thing. It's simply part of the arc. The quiet. After the concert. The darkness that follows the sunrise and sunset of billions of years. Not so curl up now. And picture the universe, vast and dignified, dimming gently not in despair, but in peace. Not with violence, but with grace. Because sometimes the most beautiful stories end softly. Now that the galaxies have faded and star birth has all but ceased, what remains in the growing dark? Black holes. Not the monsters of sci-fi movies. Not dramatic portals or swirling drains. Just quiet, patient, inevitable. As the universe continues its long descent into silence, black holes become its main characters, not because they're loud, but because they're what's left. Picture them scattered across the dark, some small, born from collapsing stars long ago, others vast, formed at the centers of galaxies, loaded with everything they've devoured. They sit motionless, like deep wells in space, invisible until you're too close to turn back. Gravity made solid. Mainstream physics tells us that black holes aren't just dense, they're the densest things known. Squeeze a star into a pinhead and you're close. What makes them chilling is how little they change. While everything else winds down, black holes just keep being. And for a time, an incredibly long time, they will rule the universe. Eventually, all matter that hasn't decayed will either fall into a black hole or escape into the infinite dark. The last stars red, dwarfs on their final flickers, will be swallowed. The final gas clouds, frozen and wandering, will be eaten. Even the rogue planets, drifting alone like marbles in the night, will meet their end in silence. But it doesn't happen fast. In fact, black holes age so slowly, it's almost funny. Hawking radiation, a tiny quantum whisper at the edge of the event horizon, causes black holes to lose mass very, very slowly. Over unimaginable stretches of time, they shrink. Here's a mainstream fact for bedtime. A supermassive black hole, like the one in the center of the Milky Way, could take over 10 years to evaporate. That's a 1 followed by 100 zeros. A number so big your dreams could wander through it for lifetimes and never hit the edge. Now for something fringe and fascinating. Some theorists suggest that black holes might not truly vanish. Maybe the final stage of a black hole's life doesn't end in silence, but in a bounce, a release of information, like a cosmic sigh. We don't know, and maybe we never will. But that mystery? It hums like a lullaby across the void. And if black holes do evaporate, the universe enters a new era. Cold, empty, almost completely still. No stars, no planets, no light, just particles far apart, barely interacting, moving through the ghost of what used to be a vibrant cosmos. But for now, in this chapter of the long night, black holes are still out there, drifting slowly through. Darkness, ancient and unstoppable. They don't glow. They don't shout. But they last. So if your thoughts feel heavy tonight, if sleep won't come easy, imagine yourself floating near one of those quiet giants. Its edges perfectly smooth, its gravity endless, its presence timeless. There's no rush, no noise. Just the universe holding its breath for a very, very long time. The stars are gone. The galaxies are quiet. But the night goes on. Now that the galaxies have faded and star birth has all but ceased, what remains in the growing dark? Black holes. Not the monsters of sci-fi movies. Not dramatic portals or swirling drains. Just quiet, patient, inevitable. As the universe continues its long descent into silence, black holes become its main characters, not because they're loud, but because they're what's left. Picture them scattered across the dark, some small, born from collapsing stars long ago, others vast, formed at the centers of galaxies, loaded with everything they've devoured. They sit motionless, like deep wells in space, invisible until you're too close to turn back. Gravity made solid. Mainstream physics tells us that black holes aren't just dense, they're the densest things known. Squeeze a star into a pinhead and you're close. What makes them chilling is how little they change. while everything else winds down. Black holes just keep being, and for a time, an incredibly long time, they will rule the universe. Eventually, all matter that hasn't decayed will either fall into a black hole or escape into the infinite dark. The last stars red, dwarfs on their final flickers, will be swallowed. The final gas clouds, frozen and wandering, will be eaten. Even the rogue planets, drifting alone like marbles in the night, will meet their end in silence. But it doesn't happen fast. In fact, black holes age so slowly, it's almost funny. Hawking radiation, a tiny quantum whisper at the edge of the event horizon, causes black holes to lose mass very, very slowly. Over unimaginable stretches of time, they shrink. Here's a mainstream fact for bedtime. A supermassive black hole, like the one in the center of the Milky Way, could take over 10 years to evaporate. That's a 1 followed by 100 zeros. A number so big your dreams could wander through it for lifetimes and never hit the edge. Now for something fringe and fascinating. Some theorists suggest that black holes might not truly vanish. Maybe the final stage of a black hole's life doesn't end in silence, but in a bounce, a release of information, like a cosmic sigh. We don't know, and maybe we never will. But that mystery? It hums like a lullaby across the void. And if black holes do evaporate, the universe enters a new era. Cold, empty, almost completely still. No stars, no planets, no light, just particles far apart, barely interacting, moving through the ghost of what used to be a vibrant cosmos. But for now, in this chapter of the long night, black holes are still out there, drifting slowly through. Darkness, ancient and unstoppable. They don't glow. They don't shout. But they last. So if your thoughts feel heavy tonight, if sleep won't come easy, imagine yourself floating near one of those quiet giants. Its edges perfectly smooth, its gravity endless, its presence timeless. There's no rush, no noise. Just the universe holding its breath for a very, very long time. The stars are gone. The galaxies are quiet. But the night goes on. So here you are, floating through a universe stripped of stars, stripped of structure. No light, no heat, just distance. Whatever matter survived the slow proton decay now exists as individual particles, stray electrons, lonely photons, the occasional ghostly neutrino. They're still here, sure, but they're not doing much. It's like a ballroom after the dance, where a few confetti pieces are still lazily drifting down, long after the music has stopped. This is the dark era of the universe, the final act, and it's not tragic, it's not violent, it's just quiet. A kind of cosmic afterglow, so stretched and faint that even light barely bothers to move anymore. Here's your mainstream bedtime fact. Over time, the expansion of the universe continues accelerating due to what we call dark energy. So those last few particles, they're getting farther and farther apart. Eventually, there will be so much space between them that they might never interact again, not in 1 trillion years, not in 1 trillion. Imagine an electron waving goodbye to its neighboring particle, and never seeing another one again, for the rest of time. That's not loneliness in the human sense, it's just physics. Still, there's something poetic about it. A universe that once blazed with stars, now reduced to the slow drifting of nearly nothing. And now for something fringe, yet fascinating. In some versions of quantum theory, the vacuum of space isn't empty. It boils. Tiny virtual particles pop in and out of existence for the briefest flickers of time. So even in the darkest era, the vacuum itself might still shimmer with ghost activity, flickers too faint for any eye to see. There's also the unresolved debate over whether information can ever truly be destroyed. Some theorists argue that even if every atom decays, the information they carried might remain, written somehow into the structure of the universe. Like footprints on the surface of water, barely visible, but never quite erased. So what are we left with? A few elementary particles, ever more scattered. Some background radiation stretched so far, it's colder than cold. And space, so much space, it defies imagination. There will be no new stars, no galaxies, No gravity wells to collapse into something dramatic. Just the occasional blink of virtual particles, and the silent song of time without tempo. If you're still awake, you might be wondering what this all feels like. The answer is, it doesn't. There are no minds left to feel it. No creatures to look up and wonder. No one to say, remember when the stars used to shine? But for us, here and now, there's something strangely comforting in imagining it. The thought that even as everything fades, it does so gently, without panic. A slow return to simplicity. Not a scream, but a sigh dot. And in this sigh, you float. Weightless, timeless, peaceful. At this stage in the cosmic story, even the concept of a moment has become slippery. Time, as we know it, was once tightly bound to events. It was something you could measure by the heartbeat of a star, by the flicker of a flame, by the soft tick of a planet orbiting its sun. But now, with nothing left to mark its passing, what is time? You drift through a universe where clocks have no gears, where nothing moves fast enough to be seen, where a second could be a century, and a billion years might pass like a blink or like forever. There's no one to know the difference. Here's the grounded academic reality. In physics, time is not some eternal flow. It's a measurement of change. Without change, without movement, friction, transformation, time loses its teeth. It becomes soft, malleable, a line with no landmarks. In the far future, when even atomic decay has ceased, time might be technically running, but nothing would notice. And here's something wonderfully weird to tuck under your cosmic pillow. There's a hypothesis called the thermal time hypothesis. It suggests that time is not a universal constant, but something that emerges. From heat, no time. So in a universe where everything has cooled to near absolute zero, maybe time just stops. Not like turning off a light switch. More like drifting into still water and not noticing the current has faded. In this state, particles, if any, are left, no longer bounce or decay. They just exist. Spread impossibly thin, surrounded by a vacuum that's infinitely stretched and almost perfectly cold. The temperature of the universe approaches absolute zero, a place where even quantum activity becomes a rare whisper. And that's the strange beauty of this era. It's not a final crash, but a smooth fade into stillness. No explosion. No collapse. Just the universe doing what it does best, changing slowly, until there's nothing left to change. So where are you in this picture? Floating, listening, resting inside a universe that has forgotten motion. Your breath the only wind, your thoughts the only sparks. In this silence, you realize something gentle and surprising. Even in absolute stillness, there's a strange sort of presence. A quiet awareness, not of action, but of being. Because even if time forgets the universe might still remember time. And maybe that's enough. Let's imagine something a little eerie. The universe now is cold, empty, and quiet. But here's the unsettling twist. There's no one left to know it. In the entire endless stretch of space. There are no eyes to see, no ears to listen, no minds to wonder. No curious life forms recording data, asking questions, or naming constellations. The cosmos has finally arrived at a place it had never truly been before. A universe without observers. It's strange, because we often assume the universe exists in a certain way. We talk about how long it will last, how far it stretches, what might happen next. But all of that language, duration, size, future, is based on perception. On someone, somewhere, being able to notice, compare, and remember. Without consciousness. What does it even mean to say that time passes? Or that space expands? Here's a proper fact to steady us. Some branches of cosmology describe this as the heat death of the universe. Not dramatic, not fiery. Just a gradual flattening of everything until all usable energy is gone. The laws of thermodynamics predict it. Entropy demands it. Now, here's something from the fringe shelf of cosmic theory. Some physicists speculate that observation itself might shape reality. Not in a magical, you create your own universe kind of way, but in a subtle, quantum sense. That without an observer, some aspects of reality might remain undefined, fuzzy, indeterminate, Schrödinger's cat, writ large, purring or not, into a lifeless universe. And so you drift, not just through space, but through a profound absence. Not just a silence of sound, but a silence of meaning. If a galaxy fades in the dark, and no one is there to watch, does it still disappear? The answer, it seems, is yes. But it's also more than that. There's a kind of peace in this observerless universe. Like a theater after the audience is gone. The stage cleared, the curtains drawn. The performance was long, beautiful, terrifying, and now it's over. The set remains for a while, but even that begins to dissolve. Still, even without life, the memory of life lingers. In a sense, the structure of the universe is still shaped by all the things that once lived and burned and questioned. You, lying, here now, are part of that story. You've observed it, felt it, imagined it, and that observation matters, Dot. So even in this cold, quiet stretch of eternity, you carry with you something the universe cannot erase. The echo of awareness, not a flicker. OF thought in a cosmos that will one day forget how to remember. By now, you may be thinking, is this really the end? Is the universe truly destined to just stretch out forever, cooler and lonelier with each passing eon, until everything dissolves into stillness? Well, maybe. But then again, some theories whisper a different story. A story not of fading, but of returning. A cosmic loop. A breath drawn back in. Let's float through that idea together, Dot, in some corners of theoretical physics. There are models that suggest the universe could be cyclical. That after this long expansion, after all the silence and scatter, something could pull it all back. Not metaphorically, but physically. A kind of cosmic boomerang, swinging wide into the void, only to eventually reverse direction and return. This concept is known as the Big Crunch. It's an idea that once held strong favor before the discovery of dark energy. In this vision, gravity eventually overcomes the expansion of space and begins pulling everything back inward. Galaxies, stars, atoms, the stretched out skeleton of space-time itself. Imagine the universe in rewind. Clusters reform, stars reignite, temperatures rise again. Matter condenses into dense knots of heat and pressure, until, finally, it all collapses into a singularity, not unlike the one we think the Big Bang sprang from. And then, maybe it all begins again. That's where the Big Bounce theory comes in, sort of rebirth following the collapse. In this version, the death of one universe is the birth cry of the next. And on it goes. An infinite breath. Expansion, contraction, rebirth. Now, here's your academic curiosity nugget. While these models are elegant and oddly poetic, they face serious challenges from current observations, especially the measured acceleration of the universe's expansion. Dark energy, if it continues behaving the way it seems to, would make a big crunch almost impossible. Still, physicists debate the nature of dark energy and whether it might change over time. It could slow. It could reverse. It could surprise us. And for the fringe dessert on this theoretical buffet, in some exotic versions of quantum cosmology, you might not even notice the universe looping. Each cycle could create a different version of physical laws, or even time itself. It might be like dreaming one long sequence, and then you wake into another dream with no memory of the last dot. So, could we be living in just one page of an endlessly flipping book? Could the silence of the heat death be followed by a thunderous chord of creation? Or was the Big Bang not the first sound, but merely the most recent? You drift through this possibility, like a leaf in reverse gravity falling upward into a past that hasn't happened yet. There's something oddly comforting in the idea that nothing is ever truly gone. That the universe, like a sleepy tide, may one day turn again. But for now, it remains a question without an answer. A lullaby without a final verse. And you, gentle explorer, continue floating through the long pause between notes, listening. What if the end of this universe is just one note in a much larger symphony? You're lying here, still and small in the long hush of cosmic twilight, but above you, beyond you, beside you, are other universes, slipping through time in ways we can't even imagine. Universes that are ending, too, but differently. Welcome to the soft spiral of the multiverse. Now, This isn't just science fiction. Some interpretations of quantum mechanics, cosmology, and string theory propose that our universe is one of many, an infinite garden of realities, each born with its own laws, constants, beginnings, and yes, endings. Some of these may be bursting with energy, even now. Others may have fizzled out eons ago. A few may loop forever, never knowing stillness. And some might be in the final phase, like ours, cold, stretched, quiet. Let's anchor this idea with a widely respected theory: eternal inflation. After the Big Bang, space itself may have expanded at different rates in different regions, like bubbles forming in a boiling pot. Each bubble is a universe. Ours is just one of them, floating in a larger froth we'll never see. So, here's a strange idea to doze off with. Maybe our universe's end isn't the end. It's just the closing of a single page in a much thicker book. And now for the fringe. In some theories, these universes might occasionally collide. A moment of chaotic overlap, big, dramatic, and unknowable. One such collision could even have caused our Big Bang. The universe you're lying in may have been born from the ashes of another, in a cosmic accident we can never replay. So what happens in these other endings? Maybe one universe burns out. In a slow spiral of light, another collapses instantly. A third drifts in perfect stasis, where time stands still and nothing ever changes again. In some realities, time could run backwards. In others, there might be no such thing as time at all. It's as if reality keeps writing new stories, each with its own beginning, middle, and end. And we're characters in one chapter, glancing at the faded ink of others. If you close your eyes, you might imagine them, not as parallel lines, but as scattered stars in a night sky made of possibilities. Some fading, some flaring, some just beginning to glow. And maybe, in some distant universe, someone else is wondering the same thing. Am I the only one drifting toward the end? Or are we all across infinite pages whispering the same sleepy question into the dark? Now let's fold inward even more. Not just towards space or stars or matter, but towards something stranger. Something you're soaking in right now without noticing it. Time. Will time ever end? Not your time, not my time, but time itself. That deep, invisible tide we all drift upon. You might think of time as a constant companion, a steady rhythm that ticks through your day. The clock beside your bed, the slow swirl of seasons, the shift in shadows at sunset. But on a cosmic scale, time is slippery, mysterious, possibly even fragile. Here's a mainstream idea to hold in your hand like a pebble. According to general relativity, time is not separate from space. It's fused with it. A single fabric, called space-time. As the universe expands, so does time. It's not a backdrop. It's a player in the game. But if space stretches so far it frays, what happens to time? In some far future scenarios, time may not stop so much as fade. In a heat-death universe, silent, dark, stretched thin, there may be no more events to measure, no more processes, no more before or after. Just stillness. A timeless sea where clocks have no meaning and memory has no place to stand. One academic argument comes from the arrow of time, a concept tied to entropy. Right now, time moves forward because things fall apart. Ice melts, smoke disperses, people age. But in a universe where nothing changes, where entropy is maxed out, the arrow may break. Time could become directionless or meaningless. And now, a fringe possibility. Some theorists propose that time itself is emergent, not a fundamental property of the universe, but something that arises from deeper layers of physics, like temperature emerging from molecules moving. If that's true, and when those deeper layers quiet down, time may dissolve entirely. You might wonder, without time, what's left? Strangely, maybe everything. Maybe nothing. A frozen pause that stretches forever. Or a silence so total that even forever becomes irrelevant. It's like trying to describe color to someone born into darkness. And yet, we're here, still, moving through time, still unfolding, still listening. In your room, your clock still ticks. Your chest still rises and falls with every breath. But in the cosmic distance, a question hangs like mist. Will that ever stop? Will the ticking of time someday just not be? Maybe, maybe not. But for now, your own arrow of time floats gently forward. And that's more than enough. So here we are, tiptoeing along the final edge of the cosmic timeline. Galaxies are scattered, stars have blinked out, black holes have long since evaporated, and the silence is absolute. The story, it seems, is over. But is it? You're lying? Back, still, quiet, wrapped in blankets and questions. And in the hush of that infinite night, another thought stirs. What comes next? Because endings, true endings, are rare. Even in our own lives, most things fade, echo, or transform. The final scene of a film lingers in memory. The last leaf of autumn decomposes into spring. A lullaby ends, but its rhythm rocks you into dreams. Might the universe be the same? Some speculative cosmologists think so. One theory is the Big Bouncer. Twist on the Big Bang. It imagines the universe not as a one-way ride, but as a cycle. Expansion followed by collapse. Then expansion again. Birth, death, rebirth, a heartbeat, stretched across eternity. In this view, our universe could be just one iteration in a looping timeline. After the long freeze, something triggers a reversal. Maybe dark energy changes sign. Maybe a quantum fluctuation wakes space from its sleep. Suddenly, contraction begins. A slow pull inward. Galaxies drift back together. Heat concentrates. Time speeds up. And then, at the singularity, where everything compresses into one blinding point, it happens. Another bang. Not a rewind, not a reboot, but a sequel. New physics, new constants. A different kind of light. And with it, maybe new forms of consciousness, linking into awareness for the very first time. Somewhere, someday, someone else may gaze up and wonder how it all began, never knowing. They're walking across the ashes of our universe. But this isn't the only vision of what comes next. Some believe in baby universes budding off from ours, like bubbles forming on a soap film. Each tiny universe pinching off with its own destiny. A chain reaction of births, branching forever. Others suggest that what we see as the end is only the collapse of our observable region. Beyond it, new regions may still be inflating forever, spawning stars, laws, and minds. And if time, as we know it, is part of this universe, then perhaps something outside it doesn't need time at all. A state beyond beginnings or endings. Just being. Now, that's hard to wrap your sleepy brain around. But that's the beauty of it. Maybe the ending is more like an ellipsis than a period. And here you are, nestled into your blankets like a star, curling inward for its long rest, dreaming on the edge of forever. Because even if the universe ends, maybe the story doesn't. We've traveled a long way tonight, haven't we? From the explosive birth of time and space, to the slow unraveling of galaxies and stars, to the fading embers of a universe entering its final stillness. And now we return softly, quietly, to the only perspective we can truly know. Ours. What does the end of the universe mean for you? You lying there in the dark. You breathing gently beneath a blanket. One small human body on one tiny planet, orbiting one ordinary star in a vast, uncaring sea of galaxies. And yet, you care. You wonder. You ask. The cosmos may be cold, but you are warm. And that contrast, that tiny spark of awareness, against the backdrop of forever, is something miraculous. Some philosophers argue that the universe doesn't end when stars die or matter decays, but when meaning fades. When there's no one left to watch the stars vanish, no one to remember what it all was. Others disagree. The universe has its own kind of dignity, its own silent unfolding, whether witnessed or not. But still being witnesses changes everything. You see, humans are experts at endings. We carry them in our bones. The final page of a book. The last day of summer. The goodbye whispered at an airport. We know how to feel the closing of things. So when we imagine the universe ending, we naturally reach for emotion. Grief, wonder, stillness, a little fear, a little awe, maybe even A strange kind of peace. Because if the cosmos has a final chapter, we're already part of it. Every thought you've ever had, every breath you've taken, has been shaped by the universe's timeline. Your body was built from exploding stars. Your mind runs on rules set in motion 13.8 billion years ago. And yet, you choose to wonder about all of this. There's something deeply poetic in that. You weren't required to care. The universe never asked for your attention. But you gave it anyway. So maybe that's what truly lasts. Not atoms or light, or even space itself, but awareness. The quiet act of noticing, of asking questions, of imagining the far end of all things, and still feeling curious. Here's one last thought, just for you. Even as stars fade, even as time stretches thin, even as the galaxies drift beyond reach, the fact that you are here, now, listening, breathing, dreaming means the universe hasn't gone dark just yet. You are its echo, its whisper, its last flicker of warmth in the deep freeze to come. And maybe, just maybe, that's enough. Now that we've wandered to the edge of forever, let's take a moment to simply float here, no rush, no direction. Just you, and the soft hum of cosmic silence. Because at some point in the future, not next year, not next billion years, but long after the last photon of visible light will be emitted. That's right. One day, light itself will die. How strange that sounds, doesn't it? We think of light as eternal, as the stuff that defines the universe, stars shining, sunsets glowing, galaxies stretching like jeweled scarves across the night. But in the end, even light gets tired. Stars will have long since run out of fuel. No new stars will form. The galaxies that once glittered will grow dark, filled only with a pale afterglow of heat, slowly dispersing into cold nothing. The universe will become a place without contrast, without shimmer, without shadow. A sea of absolute sameness. It's called the Dark Era. And no, that's not just a cool band name. It's a real projected phase of cosmic history. In this distant twilight, even black holes will finish their final act. They'll evaporate via Hawking radiation, losing mass over quadrillions of years until, poof, gone. No bang. Just a whisper of energy, dissolving like sugar in water. And after that, only particles. Cold, stable, lonely particles drifting through a space so stretched that they'll likely never meet again. No reactions, no friction, no movement worth noticing. And here's the unsettling part. Time still flows, but nothing changes. It's like a clock ticking in an empty room for eternity. There's something eerily elegant about that. A universe that began in fire, thunder, and impossible energy quietly fading into a near-perfect stillness. Not tragic, not even sad, just complete. And maybe that's the part we struggle with most. Completion. We're so used to cycle sunrises and seasons, breathing and blinking, beginnings and ends that lead to new beginnings. But this is a one-way ride, a grand finale with no encore, a final page no one will turn. And yet, despite the fading of light, there's beauty in imagining it, in thinking about a darkness so complete that it becomes its own kind of illumination. A silence so deep that it hums. Maybe that's why you're still awake, in a world where most things are loud and fast. You're drawn to the quiet, to the still, to the idea that, at the very end, the universe isn't destroyed, it simply rests. And you're still drifting there, wrapped in that story. One last little light, listening as the universe whispers its final lullaby. Word count, 1098. So, is that really it? The lights go out, the last black hole exhales its fading breath, and the universe dissolves into cold, quiet particles? Maybe, but also maybe not. Because you see, the universe has a reputation for surprises. It was never supposed to exist in the first place. Not in this precise way. Not with such balance, such mystery, such delicate defiance. So it's only natural that some physicists and philosophers dare to ask, what if it doesn't end? What if something comes next? Let's whisper through a few of the possibilities. One of the more dazzling theories is called the Big Bounce. Imagine this: the universe expands, cools, fades, And then, for reasons not entirely clear, it begins to contract. Slowly at first, then faster, gathering itself like a breath held too long. Eventually, everything collapses inward. All the galaxies, stars, dark matter, and forgotten dreams compressed into a single, unimaginably dense point. And from that, a new universe might explode outward. A rebirth. A reset. Now, there's not much evidence for this. In fact, many physicists lean toward a different idea, that the expansion of the universe will continue forever, and there's no bounce at the bottom of the hill. Just the long slide into nothing. But still, the idea lingers like an echo. That, maybe, in a realm beyond our physics, there's some deeper rhythm at play. A cosmic inhale and exhale. Sleep and waking got another possibility? Something weirder. Quantum resurrection. Some interpretations of quantum mechanics suggest that if the universe is infinite, and if time is infinite, then given enough time particles could randomly rearrange themselves into anything. Even into a new universe. Even into you, blinking back into existence after untold eons? Sound ridiculous? Well, the math doesn't entirely rule it out. In fact, it suggests that not only could it happen, but if time stretches on forever, it's statistically guaranteed to happen. Eventually. But don't pack your suitcase for Universe 2.0 just yet. These ideas, while thrilling, are on the very edge of what science can explore. Beyond the boundary where evidence ends and speculation begins. That place where curiosity walks hand in hand with wonder. And honestly, that's where you are right now too. You're not just learning about the universe. You're doing something stranger. You're dreaming about it. Asking it to show you its secrets, even if those secrets are buried in time that hasn't happened yet. So could something come after the end? Maybe not in a way we'd recognize. Not in timelines or galaxies or voices, but perhaps in possibilities. In the idea that existence doesn't have to be done. That maybe there's a version of forever where even silence isn't the final word. And you, still awake, still curious, are part of that idea now. There's something quietly astonishing about how the universe keeps records. Even in its emptiest corners, nothing is ever truly forgotten. Particles leave traces. Light carries messages. Gravity records movements like ink pressed into space-time. It's not like your bedroom floor, where socks disappear into another dimension. No, this cosmos is a library that never stops writing. Let's start with a simple thought. Everything leaves a mark. When a star is born, when it burns, when it dies, it sends ripples through the universe. Not just light and heat, but gravitational. Waves, tiny tremors that stretch the very fabric of space. We've only recently learned to listen for these whispers. With machines so sensitive, they can detect a ripple, a thousandth the width of a proton. But those waves have been traveling forever, gently curling through the dark. Even light, which we think of as fleeting and fast, is a kind of memory. The stars you see when you look up tonight, many of them are long gone. You're seeing ancient messages, postcards sent thousands, sometimes millions of years ago. And yet, they're still arriving. The universe lets us read them, even now. There's a haunting comfort in that. Nothing happens unnoticed. Here's where things get even stranger. There's a theory in physics called the holographic principle. It suggests that everything that happens in a volume of space, everything you do, think, feel, could actually be encoded on the boundaries of that space. As if the universe is one giant projection, and the real information is written on the MVM. Cosmic walls. Sounds like a sci-fi plot, but it's serious science. Black holes helped us realize it. When something falls into a black hole, it's not just lost. Its information is smeared across the black hole's surface area like a fingerprint on a cold mirror. The universe doesn't forget. It just files. Things in strange places. This matters, because even in the future, where all light dies and particles drift alone in cold silence, the information might still be there, locked into the structure of space, frozen into patterns, echoed in quantum fluctuations, like notes on the last page of a book that no one reads, but which still exist. And maybe, just maybe, that means some part of you, your molecules, your Thoughts, your stargazing nights, are folded into the universe's memory. Not in a way that you could reassemble and recognize, but in a way that says, you were here. And the cosmos knows it. So even if the end is quiet, it's not empty. It's full of the traces we leave behind. The warmth of vanished stars, the gravity of forgotten worlds, the footprints of light on the endless snow. Maybe that's the real point of it all, not to last, but to matter. You might be thinking, all this talk of black holes and entropy and infinite stillness, what does that have to do with you? But here's the thing. You're not separate from the universe. You're not just watching the story unfold. You're in it. Every breath you take, every time your heart flutters at the sight of the night sky, every passing thought, it's all tangled into the fabric of this cosmos. Let's play with a small idea. A cup of tea. You make one tonight. Steam curls upward. The scent of chamomile drifts softly through the air. Now physics tells us that the molecules of that steam will never come back together in the exact same way again. That cup of tea, that moment of warmth, it's unique, unrepeatable, but not meaningless. Those molecules keep moving. Some escape the room. Some are breathed in. Some get caught in clouds, drift across oceans, fall as rain. It's chaos, yes, but it's patterned. Chaos, ripples on a pond that never really stop. This is how small moments matter, because everything you do has echoes. The warmth of your body shifts the air. Your voice sends vibrations into walls. The thoughts you think create electrical storms inside your brain that, however fleeting, change you. That change adds up, slowly, softly, but forever. Here's a real historical fact. In 1964, two scientists named Penzias and Wilson accidentally discovered the afterglow of the Big Bang while trying to get rid of static on their antenna. What they found was the cosmic microwave background, the faint leftover radiation from the birth of the universe. It's still here. It's everywhere. You're literally bathed in it right now. A weird fact? The atoms in your body don't just come from stars. Some of them come from supernova, the most violent explosions in the universe. You're carrying around tiny souvenirs from ancient cosmic catastrophes. And here's the big academic debate. Some scientists argue whether information from all interactions, no matter how small, can truly be lost. Others insist that every quantum event leaves behind an imprint that persists, forever altering the state of the universe. We don't yet know which is true, but both ideas suggest that everything counts. Even your quietest day. Even now. When you listen to stories like this, drifting off under the blanket of dark skies, you're becoming part of the universe's thinking. It's dreaming. It's deep, silent curiosity. You're a ripple too. So when it all seems too big, too fast, too far beyond your reach, remember the tea. Remember the steam. And remember that sometimes the gentlest things, like gravity, like a soft whisper, can change everything. Don't need to move stars to matter. You already do. Imagine the final chapter of everything. No explosion. No grand curtain drop. Just quiet. A long, slow exhale. The stars blink out one by one, like dying candles. Galaxies stretch farther apart until light can no longer reach across the dark. Time doesn't stop, but it forgets what it was keeping track of. This is the far future. The kind you can't circle on a calendar. We're talking quintillions of years from now. Whole languages will have vanished. Even atoms will grow tired. It's called heat death, but it's not the kind of death with drama or fire. It's the universe reaching thermal equilibrium. No more gradients. No more usable energy. Just sameness stretched everywhere. A flat sea of silence. But before that stillness, there's a whole saga of strangeness. White dwarfs will cool into black dwarfs. Invisible cinders drifting through space. Once in a trillion years, one of them might collide with another and create a single brilliant spark, but those flashes will be rare. Like finding a lightning bug in a forest the size of a galaxy. Planets will keep orbiting the ghosts of stars. Moons will fall. Gravity will sculpt its last works, patiently folding time like origami. The last black holes will shrink and vanish in quantum whispers. releasing their mass as a soft sigh of radiation. This is a universe that doesn't die. Violently, it evaporates. And still, something might linger. Quantum fluctuations. Tiny blips of uncertainty. Like the sound of one hand clapping in the dark. Maybe new universes bud from these silent seeds. Maybe they don't. Cosmologists argue about it over cold coffee and whiteboards filled with equations that stretch to the edge of reason. But here's the part that matters. You existed in this story, with your tea and your laughter and your questions about light and time. You thought about the universe. You cared about it. And the universe, in its quiet way, noticed. We like to think that stories need endings. But maybe this one doesn't. Maybe the end of the universe isn't a period. Maybe it's an ellipsis. A soft pause. A blank page waiting to be filled again. Somehow. And you curled up, listening in the dark. You are part of the sentence. Maybe the best part. So now, just take a breath. Let the weight of everything we've wandered through settle gently in the back of your mind. From the birth of stars to the whisper of entropy, from the dancing of atoms to the fading of galaxies. This has been a slow unraveling, like watching the tide pull softly at the edges of time. And here you are, still, quiet, warm, drifting beneath your own sky. You've traveled billions of years tonight without moving an inch. You've seen the universe burn, grow, stretch, darken, and through it all, you listened. Not to rush toward an answer, but to linger in the question. That's something rare. Something beautiful. Your breath is part of this rhythm now. Inhale and imagine the hydrogen that lit the first stars. Exhale and let go of everything for a moment. Just float. There's no rush. No need to hold on tightly. The universe has been patient for billions of years. It will wait a little longer while you rest. You are stardust that became aware of itself. You are a moment of softness in an ancient story. And even as everything cools, even as the lights go out one by one across the cosmos, this moment you're in right now is still glowing. Let it glow a little longer. Sink into it. Let the stillness take over. Let your thoughts stretch out like light, traveling through space, gently fading into peace. Sleep well, traveler. You've gone farther than most ever will, without ever leaving your bed.